Precision and accuracy. We use these words interchangeably a lot, but they really don't mean the same thing in science. Precision has to do with exactness. So if you were traveling and someone asked where you were from, you might say Georgia. And they might say, well, I've been to Georgia before. Where in Georgia are you from? And so you might say, well, I'm from Southeast Georgia. Or you might say Savannah. And perhaps they say, well, I've been to Savannah before. Where do you live in Savannah? And you might say, I live in the Islands area, or I live in Ardsley Park. And they would go, oh, my friend lives in Ardsley Park. Where do you live in Ardsley Park? And you'd say, I live at 500 Washington Avenue, which is the school address. And so each time you told them where you lived, you told them in a more exact fashion. You were more precise about describing where you lived. Accuracy, on the other hand, is correctness. There was nothing incorrect about any of the descriptions that you gave that person. You do live in Georgia. There's nothing wrong with that. You do live in Savannah. And if you live at the school, you live in Ardsley Park, and you live at 500 Washington Avenue. Each of those answers gets more and more exact or precise, but they're all equally correct. So accuracy has to do with correctness. Precision has to do with the exactness of a measure or the fineness of a measure. Why might an old worn meter stick lack accuracy? Well, as you will find, when you go in the lab and you have a meter stick, it's very typical for students to bounce them off the floor. Or just in the course of their normal use, the ends get a little bit worn. And so if the end is worn off your meter stick, it's not exactly a meter long. And so when you make measurements with it, your measurements might be off because some of the meter stick is missing, which would make your answers less accurate. Would it lose precision too? Well, no, because all the little tiny lines that are on the meter stick that give us the precision, that allow us to measure to the 1/10 of a millimeter, would still be there. And so the precision would be there, but the accuracy of our meter stick would be off. Everything that we use to make measurements in the lab has a certain precision. I mentioned that our meter sticks are precise to the 1/10 of a millimeter. They have little millimeter lines, and we can estimate one place beyond the lines that are there, and so they're precise to the 1/10 of a millimeter. When we make measurements, we have to use the device and represent the precision of that device as well as we can. So if I used a meter stick, I wouldn't just say something was 1/2 a meter. I would say I would have to record that measurement to the 1/10 of a millimeter. So I need to carry out the place values that represent what's possible with that device. And when we then do calculations with those measurements, like if I were measuring length and I needed to calculate area, or I were measuring length and I needed to calculate a perimeter, those calculations need to maintain the precision of the device that we were using to do the measuring. This is a meter stick. This is the 30 centimeter mark, 31 centimeters, so the distance between the longer lines is a centimeter. Each of these little short lines is a 1/10 of that distance, and so they are a millimeter. When you're using a device, you can estimate one place beyond the markings that are on your device. And so when I use a meter stick, I need to record the precision to not to the centimeter, not even to the millimeter, but to the 1/10 of a millimeter. So if you're measuring something that's this long, it's somewhere between 30.1 and 30.2 centimeters, and you would have to make an estimate of where it lies between that millimeter marking and that millimeter marking. This is a graduated cylinder. This graduated cylinder isn't as precise as the meter stick that we were just using. This is 70, and this is 80, and there are 10 lines in between. So those 10 represent milliliters, so 1,000th of a liter. And so if the level of the liquid we were looking at was right here, then we would say, well, here's 70, here's 71, here's 72. I'm going to estimate that it's 71.5, or maybe it looks more like 71.6 to you. That last digit is uncertain, and so you estimate to that place value. this is a balance. Balances have little slidey things that we move back and forth, and when um, the weight that we put, the unknown weight that we're putting on the balance to measure it, balances, then we read all of these readings together to get the value. This balance is set up with something fairly light, and so the 200-gram slider is not it's not engaged. It's all the way on the 0 mark, and the 100-gram slider is all the way on the 0 mark. The 10-gram slider is right here, and it's on the 7. So that's 7 grams. And then the smaller slider is here. It's the 1-gram slider. So if this silver thing were all the way out here, then that would indicate 1 gram. But it's right here. So this is 0.8 grams. This is 0.9 grams. So this is 0.88. This is 0.89. So it's somewhere in between. So 0.887, 0.888. You would have to estimate and choose what you think is best for that last digit. So a reasonable reading of that would be 7, the 7 from here, 0.887 grams. If the small slide were exactly on the 0.9, instead of here, if it were right here, you wouldn't just be able to say 7.9. You'd have to say 7.900, because the device that you're using to make the measurement is precise enough for you to do that. And if you don't record that precision, you're not giving all of the information that you should about your measurement.